Okay, so let's start now the circuit. Next circuit we will proceed. So we have made in the last video we made this circuit, so in which we did the LED on off, simple LED on off. Okay, so now do you want to go in this? So this is the LED on off, and if I simulate it, which you did last time, that you can see if you want. And this is the this is the Arduino, and the code which we did last time is this, that is of inbuilt LED on for 2 seconds, inbuilt LED off for 2 seconds, and then you can do the simulation. So the this LED will become on for 2 seconds, off for 2 seconds. So this we did last time. Now if you want to add it in this, tinker this, if you click, then you can add the program in this itself. And if you want to take it save this and want to make new, and then you can go for the new circuit also. So what I am doing is I am keeping this same as, and I am doing the rename of this circuit so that we remember what we did in session 1 and session 2 that way. So what I am doing here is Arduino circuit, or session 1 Arduino circuit, that way. Okay, so session 1 is the video one. So session 1, this we have completed. Now we are going back, and now we will have the new circuit. So new circuit, the software will give the name, random name. So we will give again session 2, if we say Arduino circuit. Okay, Arduino and double आ गया ही Arduino. Okay, so session 2 Arduino circuit, that we have named it. Now we will select the Arduino again. So now what we will do is we'll connect the LED from the outside, that is the external LED will connect it. So this is the LED which we are going to use. Now this LED, you can give your name LED1, like that. Like 1 is also the name that you can keep, or you can change the name, and you can select the color of the LED, like green, yellow, orange, blue, anything. So I am selecting green. So this is LED we have connected. Now how to connect it with it? So we will connect with the 13 number. So this anode and this is cathode. Anode means positive, cathode means negative. So LED connection should be like positive battery, or the signal positive should go to the positive, and the ground should go to the ground, negative, cathode. So anode will be connected to 13, D13. Yep. And click here and place it to the ground. So we have connected the LED with the 13 number, like this. Okay, so now you can do the simulation again with this with the code. The inbuilt code, whenever you take the Arduino, this 1 second inbuilt LED code will be there in the software, so that you can use directly. So if you do the simulation, the 13 number will get LED on off, and this green color also getting on off. Okay, so this way you can do the programming, and you can change the number 1 to the wait and the seconds. How much seconds do you want to wait? Like 2 seconds. So if you want to, like, you directly press here 2, then simulation will get stopped. Again you have to start the simulation, so it will become 2 second on, 2 second off, 2 second on, 2 second off. So that way you can have the different timing with the help of this wait function. So wait is for to stop the LED for the particular time. Like you made on, so it will remain on for 2 seconds. You made off, it will remain off for 2 seconds, that way. So for the understanding, you can follow the cursor every time whenever I am speaking. So if cursor is focusing in some point, so you can have a look of that. Like I am right now focusing on set built-in LED high, wait for 2 seconds, set built-in LED low, set for 2 seconds. So the LED is on. So I'm just facing the cursor so that you can focus on that point specifically. So this LED, the L LED is also making on, and this is also having on. Okay, now here you can have the message like the LED is yeah, here. So whenever it is having off, so the message is going. So what I am doing is I am removing this off case and simulating. Sorry, I have to delete it. Yeah, so it will remain on, right? So now it will remain on though, so we can see the message. So current through the LED is 52, so recommended is 20 milliampere only. So actually recommendation for this LED is 20 milliampere. Ampere is the measure of the measurement unit for the current. So the more current is flowing in this LED, so it is not desirable to run like this. So we will use the resistor in series. So we'll stop the simulation, remove the code, and have the resistor. So resistor is used to resist the current, and it will allow the desirable amount of current. Okay, and you can select the how much resistance you want to give. Here we have kept the 1 kilo ohm, that is 1000 ohm. So now do the connection. So we'll remove this, and from 13 it will go to resistor, and resistor to positive, that way. Okay, so now if you simulate, so the no message is coming here because the LED is having a proper amount of current which is required. Now if you reduce the value of resistor here, so if I am reducing the, like I added the 0, like, so 0, we got the message here. So if I do like 0.1, okay, so 0.1 resistor will also work. Okay, so if I reducing the unit, so ohm, instead of kilo ohm I am doing ohm. So 10 ohm will not work, 100 ohm will work. So 100 ohm resistor can be used for the single LED, because single LED runs on the 1.7 volt to 3.7 volt. Okay, so that is the rating. So that we have to consider the value of resistance, how much value of resistance we should take. So 100 ohm, ohm is the unit of ohm. Ohm, I am writing the spelling OHM, ohm. Ohm is the unit of resistor, so that we have to uh, consider for this resistance. So that is the quantity of resistance it will apply during the circuit this is flowing. Okay, so this way we can use the resistor. Now again I am stopping the simulation and going into the code, and I am placing this block of low and high again, and wait again for 2 seconds like this. So you can do the 2 or 1 also, so that is not an issue. So if you do this, it is initializing. So if your internet is slow and if there is a problem, then also it will take time to simulate. Now we can see on for 2 seconds, off for 1 second, on for 2 seconds, off for 1 second, that way. So this LED is glowing like this, as we have planned here like this. Okay, so this is the circuit for the single LED. Now you can go for the circuit for the two LEDs. So if you want to connect two LEDs, like what we will do is to connect the two LEDs we have to use the two pins, digital pins. So now you understand what is digital and analog. We are getting here a digital signal output. So it is high, means you are getting 5 volt, and from the 5 volt some voltage is stored in this resistor, and some voltage is given to this LED, and so LED is glowing. Okay, so now what we are doing is we are shifting this LED to 12 number. So I am removing this, I am shifting to this 12 number. So I am using 12 number pin to make the LED on off, and 13 we are using this inbuilt LED. So we can see the two LEDs working separately, independently. Now to run the two LEDs we have to get this from LED on off from the output block. So we have the many blocks here. So we are using the output block, and to make it on off, what we'll do is set pin. So I am keeping here set pin number 12, set pin number 12 high, and set pin number 12 low. So now both will get on simultaneously, both will get off simultaneously. This is very important concept. If you think, like, it's like, if I simulate, you will understand. Both will getting on simultaneously. See, this and this, both is getting on simultaneously and both is getting off, as we have programmed it like this. Now what I am doing is, I am making off this and on this. So now when this become off, when inbuilt LED become high, the 12 number will become low. That's green become low. So alternatively it will. Now this is on and this is off. This is on, this is off. This is on, this is off. So that way alternatively it is getting on now. Now you can decide the time also here for the multiple LEDs. If you want to get the inbuilt LED a separate time, and the 12 number LED a separate time, so that also we can do. So if you what will happen in this, now this program, first inbuilt LED will get on for 1 second, then it will remain on as we have not given any signal of off. Then 12 number will become low, as it is low only, so nothing will come. Now inbuilt LED will go off. Now inbuilt LED go off for 1 second, and then LED 12 number will get high on for 1 second. So let's simulate that. So we will see that it is initializing, so it is uploading this code to this driver. As after the uploading, the program will work. So it's uploaded. Now you can see 2 second on, 1 second, 2 second, 1 second, 2 second. So alternate it is happening on. In some cases both LEDs also on. So when both LED will remain on, you have to understand this. So it will be like LED when you are making inbuilt LED high for 1 second. Now when you are making on here, so last step, 12 number high and in rotation. How this program is running, actually it is running in a rotation. So it's like, first this set inbuilt LED will get on, then this set inbuilt, this one, I am zooming this code right now so that you can understand in a better way. Okay, so what I am doing is I am zooming this complete site so that we can understand in a better way. So reduce it again and zooming this much I can zoom. Okay, so how this program is running, please understand this. First this set built-in LED will get on, then 12 number will low, then inbuilt LED low, then 12 number high, then again it will rotate and come this way. So it is rotating. This program is continuously running in a loop. Okay, it is continuously having a loop. So high, low, low, high, high, low, low, high. Let's understand with a single LED so that you can understand better. So I am removing this inbuilt LED and I am using only the 12 number. So inbuilt LED I am using, and in that inbuilt is I am removing. So I have removed inbuilt. Now 12 number only. So 12 number become low and high. So first is it become low. So there is no use of first to become low. So first it become high, then low. Then it will get the rotation high, low, high, low, high, low. High for 1 second, low for 2 seconds. High for 1 second, low for 2 seconds. That way this LED will work. See the simulation. High for 1 second, low for 2 seconds. High for 1 second, low for 2 seconds. High for 1 second, low for 2 seconds. high for 1 second, low for 2 seconds, high for 1 second, low for 2 seconds. So that way this program is running. Okay, so whatever code you are writing here, it will continuously running in a loop. So if you are writing a 4 LEDs, 5 LEDs, it will continuously running in a loop. So that this concept should be very clear, because as you will progress to add more LEDs, the confusion will create more and more. So now select the 10 number LED. So we'll shift this to 10 number, and again start the simulation. So like in 10 numbers, same we are getting. So whatever number you will place, you have to connect here with that number. And second is terminal, that the negative terminal of LED, that is cathode, should be connected to ground, and anode should be connected to this pin, digital pins. Now there one more concept we can discuss here is the position of resistor, whether to connect at the positive terminal or negative terminal, both will work. Okay, so if I connect this resistor, if I connect, so this problem you may face also. If I connect this resistor, if I deleting, I'm deleting this resistor now, and I'm connecting this resistor to uh, so you can shift your electronic components. Now take the resistor. So this is resistor. Now I am connecting this resistor to the negative terminal instead of positive of LED, so it will not harm anything. So at anywhere, any terminal you can connect, positive or negative. So negative is goes to resistor, and that is goes to ground. Okay, and this is goes to 10 number. So directly 10 resistor. So then also the resistor will means, it is not like resistor, if it is connected in front then only it can resist the electron, at backside also it will resist. So the meaning is that the electron will not will come out from this 10 number. It depends on the how much resistance is available in complete path, not in front of it, in complete path. So in complete path there is a resistance, then the electron will come out in a limited numbers only. Okay, so if resistance is not there, suppose, then if the 1000 electrons are coming, and if resistance is there, it will reduce to 50 electrons that way. Okay, so resistor position doesn't matter here, so that should be understood. Okay, so if you are not clear with this concept, please note it down that resistor concept is not clear, or the position of resistor concept is not clear. Please write this, that position of resistor concept is not clear, then we will discuss that. Okay, so whatever concept if you are not following during this video, please note it down, and we will discuss during this kind of. Okay, so this is way we can practice for the other pins. Like you can go for the next pins, so like you can connect with the third pin, like this, connect with the third pin, and you can make the LED on off. So you can understand the use of these digital pins to make this LED on off, single LED on off, or the two LED, the inbuilt and the single LED. Okay, so this is how you can understand how to use the programming to make LED on off. So you can practice it now. You have seen the video, now practice it on this Tinkerless software, and go log into your ID and make the new session 2 Arduino circuit, and then in that you make the circuit and code and try the um different coding in this, like timing and the numbers you can decide, and try to have the more and more practice of this, and try to learn how this program is working. So if you are not clear with this, then also you can write it down your doubts, and you can discuss. So that way we have completed this. Now you will practice it, and then we'll meet in the next session, that is session 3.